Hey everyone, today we are going over the ACSL, um, also known as American Computer Science League, and we're going over the junior division contests. So each contest there is coding problems, and there are also computer science topics. So today we're going to go over the computer number systems, which there are um, four that they really go over. There are binary, octal, decimal, and hexadecimal. So they all have different bases. So binary has 2, octal is base 8, decimal is base 10. It's the one that you use, the 1, 2, 3, 4, 5, 6, um, base 10, and hexadecimal is base 16. Um, So some examples of hexadecimal is hex colors. Um, when you see those, it is used with letters, and you can see there's letters here. Binary shown in like the images, the 1, 0, and with zeros. Um, in octal, you don't really see it. It's a little bit more rare. So, um, here's a list of the decimal numbers going up by 1. So decimal would go 0, 1, 2, 3, 4, all the way to 20. While binary would go 0, 1, 10, 11, 100, 101, 110, 111. Octal will go 1, 2, 3 until 24. So it would go to 6, 7, 8, 7 to 10. So it skips 8, 11, 12, 13, 14, 15, 16 and 17, and it skips 18 and 19, so that's 20, 21, 22, 23, 24. Hexadecimal, it goes up to 9, and then A, B, C, D, E, F, and then 10, 11, 12, 13, 14. So, decimal is just regular numbers. Let's talk about binary numbers. So, binary is um, zeros, zeros, sorry, zeros and ones. So, um, 1 would be 0, 1, and then when you go to the next number by 1, you move the 1 there. So that's 10, and then you add another 1, that's 11. Another, so that's 100, so you move on to that. Um, and then 101, 110, 111, and then 1, and then 3 zeros. So if you see, it goes 0, 1, and then 10. So when it goes up by 1, it just swaps those. And then when you add a 1, you just add 1 to here. So that's uh, uh so that's 11 for 3. So that's 1, 2, 3. Yeah, so that's really easy to do. So it's just a 1, 10, 1, 1, um, 100, 101, 110, 1, 1, 1, 1, and 1000, and it goes so on. So that's really easy. And octal is a bit harder. So um, converting or counting up in octal is you use the digits 0, 1, 2, 3, 4, 5, 6, and 7. So you do not use 8, 9, 8 or 9. So if you see on the graph, it's 0, 1, 2, 3, 4 until 7. Everything's fine then. And then it goes to 10 because it skips 8 and 9. So then you just skip to there. And then 11, 12, all the way to 17. And then you skip 18 and 19. And then you just continue doing that pattern. So hexadecimal is using letters after for 10. So A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. And to say 16 and up, it just does 10, 11, 12, 13, 14 until 19. So um, yeah, so that's decimal, binary, octal, and hexadecimal. So converting to decimal. So as you learned in elementary school, the decimal value of a decimal number is simply a sum of each digit. So um, this is just 1 times 10 to the power 4, so that's 10,000. 2 times 10 to the power 3, 2,000. 3 times 10 to the power 2, 300. And then 40, and then 5. So that's, just add those up, like in regular math. But the decimal value is the sum of each digit multiplied by its place value. So it goes from 0 to 3 in this case to turn it into decimal. So for example, we can have okay, so for example, we can have the binary number 1111, and we want to convert it to decimal. So to convert this to decimal, so this is the place value 0, 1, 2, and 3. So that's 1 times to the power 3 plus 2 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 1, or there should be 1. 1 times 1 times 2 to the power of 0, which will equal to 1 times 8 is 8 plus 4 plus 2 plus 1, and then that will equal this 12, 14, and 15. So the decimal number of this is 15. So as you see here, 3 times, so that's 0, 1, 2, 3, that's the third place value. So times, or here you can see 2, so this is the third place value, so that's 1 times that. So that is 13, and this is 15 in decimal. So that's converting from um, binary to decimal. Okay. So next, we're going to talk about converting from hex or octal to decimal. So octal is 8, so that's 1 times 8 to the power 2, since this is the second place value, times 8 to the power 1 times 8 to the power 0, and then you just solve that. So since it's base 8, you use 8. So like the binary steps, let's say we're converting 100 from octal to binary decimal. Then or 103. So this is 1 or 0, 1, 2. So since this is the second place value, so that's 1 times a to the power 2 plus 0 times a to the power 1 times 3 times or plus 3 times 8 to the power 0. So then that will equal 64 plus 0 plus 3, which will equal to 67 in decimal. So yes, that's how you do it. And then finally for hexadecimal to decimal, since its base is 16, you just do the same thing, but with 16. So for example, we want to do 710. So yes, let's do just 7 in hexadecimal, so that's 16 to decimal. Then since this is 0, you do 7 times 16 to the 0th, which is 7 times 1, so that's 7 in decimal. So that's actually 7 decimal, and when you check on the graph, yes, it is 7 decimal. In this example, it's using letters too, so you would do the powers of the places, and then just solve like that. So that's for today's video, and we will explain how to convert from decimal to other number systems in the next.